Aerodynamic lift. So let's look at a leaf drop pencil test one more time. See a nice drifting motion of the leaf. Now, in a previous tutorial, we talked about Bernoulli's principle, which says that when we have, say, air that is moving, the faster the air moves, the lower the pressure. So if the air is not moving, we have normal atmospheric pressure. If it's moving, the pressure decreases, and the faster it moves, the lower the pressure. Now, one of the most important applications of this Bernoulli's principle is the creation of lift for a wing. So if we have the airflow that goes fast over the top of the wing and slower underneath the wing, then we have lower pressure on top of the wing and higher pressure underneath the wing. This creates a pressure difference. Because of this pressure difference, we have a force, and we call that lift. Now, wings have shapes that promotes this difference of airspeed, but even something which is flat like a sheet of paper, if it's moving at an angle with respect to the path of action is at an angle with the orientation of the sheet of paper, then we can actually have this same wing effect of the airflow being a different speed above compared to below, and resulting in this pressure difference. Although we think of lift as being an upward force, it's not necessarily always the case. In fact, the airfoil on a race car actually is an upside down wing, and so instead of pushing up to lift the car, it actually pushes down. This is advantageous for race cars because they don't want to be flying up. They want to have better traction with the ground without adding weight. And so these airfoils are useful. But getting back to the drifting leaf, as the leaf is falling, we actually have various forces acting. There's, of course, always gravity. There's the air resistance that tends to slow the motion. And then we have, finally, the force of lift, and that can possibly deflect the path of action. It can also change the speed. If the path of action changes so that the leaf is rising, then that means that the leaf is going to slow down. As long as we don't have wind. If it's wind, then it's a different situation. Then the force of the wind can be affecting the path of action and the timing and spacing. Now, it's a very similar situation with a sheet of paper. Even if though the sheet of paper is flat, we still have these three forces of gravity, air resistance, and lift. If the paper curls, then we have even more likely to have a type of wing effect, with the airflow being different on one side to the other, promoting the lift. Now, you realize that the force of air resistance depends on the speed and the orientation of a leaf, and so does aerodynamic lift. So because both of those vary with speed and the angle, they are changing all the time, and that leads to a rather complex timing, spacing, and path of action for a leaf as it drifts to the ground. So this complexity, the best you can hope for to create a believable animation is not so much to focus on the timing, spacing, and path of action in and of themselves, but to imagine or actually feel the forces that would be acting in terms of the gravity pulling down, air resistance slowing the motion, and then lift potentially deflecting the path of action as well as the speed. So I feel a bit like Obi-Wan telling you to use the force here, but if you try to animate by feeling the forces that are acting and then trying to reproduce that timing, spacing, and path of action, you're more likely to be successful in animating this type of motion. So let's look at a paper drop pencil test, because I wanted to mention another aspect of this type of motion. So right at the end, if you see the settle as it slides on the ground, you notice an effect which here we'll see in this video as I slide these sheets of paper on a smooth surface. So you see this type of smooth gliding motion that occurs right when the paper is just off the surface of the lab table. Now, there's an additional type of lift which occurs when we have something like a smooth sheet of paper very close to a smooth surface, and this is called the ground effect lift. So the presence of this lower surface of the table enhances the amount of lift that we get. So there's an additional high pressure cushion that is produced between the paper and the table, and so that cushion, that high pressure, just supports the paper as it slides over the surface. You won't typically see this with a leaf because the shape of the leaf is too irregular, and you won't see it if the surface is rough, like the grass or dirt. One more example of lift, which is not present with the leaf drop or paper, but I wanted to mention because it's a type of lift created when an object is spinning. So if we have, say, a ball that is spinning, then the spinning motion causes the airflow to be faster on one side, where the flow goes in the same direction as the spinning of the surface, and the airflow is slower on the other side. So the side where the air is going faster is lower pressure, and then the other side is higher pressure. This gives us a pressure difference, and that leads to a force, and this is called the Magnus force, and this effect is called the Magnus effect. An example of this is when we have a baseball that's thrown and the baseball has a spin. Depending on the orientation of the spin, this can either cause the baseball to tend to rise or tend to drop faster than it would under simply gravity. Or if the spinning is in a vertical axis, then this can cause the ball to be deflected left to right or right to left, and this is a curveball. So in summary, aerodynamic lift is a force created by pressure differences arising from Bernoulli's principle. So whenever airflow is a different speed on different sides of an object, say, we have this pressure difference and a resulting force. The force of lift can either be in the upward direction, like an airplane wing, or downward, as the airfoil of a race car, or sideways, as in a curveball. Uh, the ground effect lift is an enhanced lift that occurs when a flat object is flying just over a smooth surface, like a sheet of paper over a smooth table. And finally, the Magnus effect is a special type of lift that is produced by an object's spinning motion, the spinning motion causing a difference of airspeed one side of the object to the other. Anyway, those are the uh, basic forces that occur as an object is moving through the air. So hopefully that helps you in animating that type of motion.